Hey everyone, welcome to part two. In the first part, we talked about some important terms you'll need to know, and we went through a couple of examples. And I said I wanted to leave this example for its own video. This is just because I think setting up the equation to make sure that we get our proportionalities correct, I think is very important, and I wanted to focus on it by itself. So you're often not given an amount of solute and water per 100 grams or per 100 milliliters. You're going to have to recognize that you're given a proportionality and recognize that you can use that to determine the amount of solute per 100 grams. The way you do that is you're going to set up an equation with the mass of the given mass of your solute over whatever amount of water it's planning to be dissolved in. Right, and then we set this equal to an unknown mass of solute per 100 milliliters. And this works because the equal sign means the same as. The equal sign does not mean answer. It means the same as. Whatever is present on one side of the equal sign is the same as what is present on the other side. Because on the right side we have a proportion where we have 75 grams per 400 milliliters, this ratio of numerator to denominator of 75 grams per 400 milliliters is equal to the ratio of numerator to denominator on the other side of the equation of x to 100, because equals means the same as. So now we want to solve for our unknown. We do that by multiplying both sides of our equation by 100 milliliters. And we do that because on the right side of the equation, that means that 100 milliliters in the numerator and 100 milliliters in the denominator will cancel out, because anything divided by itself equals 1, and 1x is the same as saying x. So this means that x is equal to 75 grams over 400 milliliters times 100 milliliters. Now, if you type this into your calculator, you end up with a final answer of 18.75 grams, or about 19 grams. So what that means is I'm going to take this information and then rewrite that proportion of mass of solute to amount of water in terms of 100 grams. So instead of thinking that it's 75 grams per 400 milliliters, I'm going to instead say 19 grams per 100 milliliters of H2O. Because that'll be what I'm going to be looking for on my graph, because the solubility measurements are given in terms of a mass of solute per 100 grams or milliliters. So if I know that if I know that I'm looking for the temperature at which 75 grams of potassium chlorate can dissolve in 400 milliliters of water, then I know that's equivalent to the temperature that 19 grams of potassium chlorate will dissolve in 100 milliliters of water, right? Because that proportion is the same. So I'm looking to my graph, and I'm going to look for where my solubility, where that value is about 19. So right underneath the 20 there, 19 grams per 100 milliliters of water. And then we're looking for potassium chlorate, which is over here. So it's this kind of brown-orange function. Then I'm going to come across, it's around here, and look for where this intersects with the x-axis to get a temperature. So it's between 50 and 60, and then from there you need to make a guess about what it appears to be. I think that looks to be about maybe 54. So I would say that that would be 54 degrees Celsius. And then in the end, what that means is that at around 54 degrees Celsius, that is the temperature where 75 grams of potassium chlorate would dissolve in 400 milliliters of water. So that's how you would solve these kinds of questions. Remember that we're trying to keep the proportions the same. That's why we set up the equation to be a mass over a volume, and an unknown mass over a known volume. So converting into amounts of a solute per 100 milliliters is a skill that you will need to master before you can answer some of the other application questions on this assignment. And I'm not going to be going over exactly how to do any of those, because it's not about questions being worded a certain way. It's about you thinking about what information you're given and then thinking about what do I still need to find, and how can I use this skill that I have just learned about converting to a mass of solute per 100 milliliters, and how can I use my skill of reading the solubility curve to determine if solutions are saturated or unsaturated. How can I determine temperatures and as well as solubilities given other information? How do I use those individual skills and bring them together and apply them? So that's where I'm going to leave this video. If you have any questions about anything in this playlist, please feel free to email me. If you have any questions about the assignment or it's not clear, also please feel free to let me know, and I'll be happy to go over things with you.